Yeah, another exciting episode of math from the 7th grade classroom here in Mr. Hull's virtual classroom. I'll be your friendly host as always, Mr. Hull. We're going to be taking a look today, if you will, at some exciting new things. And by exciting new, it's not really that new. It is going to be the exciting world of dun 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 similar figures. Similar figures.
What?
So we're going to take building off of what we did last time, which we did talking about congruency. Similar means maybe looks kind of the same, but probably isn't exactly the same. What do you mean? Well, thanks for asking. That's why we're about to dive right in. So if you would, please join me on page 369 as we dive into the exciting world of similar figures.
Wow.
Alright, so on page 369 we're going to talk about similar. It says, two figures that are similar mean they could have the same shape, but maybe they're not the same measurements. Ooh, crazy. So what does that mean? Well, I'm glad you asked. So if we were to have a square, for instance, because I'm pretty good at drawing squares, it's fair to say these are both what? Squares, but probably not going to be the same what? Measurement, I'd say, because it looks to me like this guy's a little smaller than this guy. So that's what it's talking about. You can have two of the same objects, but even though they look the same, they're going to be probably different size and different measurements. Alright, so let's take a gander, if we could, at example 1. It says, identify each pair of congruent figures as congruent, similar, or neither. Alright, I would probably say, if we're just looking at example 1, they seem to be about what? What would you guys say? They look pretty close to being the same. So I'd say these guys right here are what? Congruent. Just wanted to go back also and make sure you guys remembered your sign for what congruent was. So congruent means what? The entirety, both the angle measurements are the same and the segments are the same. Correct. Alright, let's take a look at B. B portion, well, this is a little crazy. It looks like you have one triangle that looks like this, and then you have the other triangle that looks something like this. I would say these are probably not what? These are not congruent, I would say. But they do look as though they could be what? Similar. And so, this right here symbol, and again, not the greatest of drawer, but this sign right here means similar. So if you're writing this on test or quiz and you want to put this beside and don't want to write out the word similar, then you can just write this little guy here and that will be just fine. Alright, so flip on over to the next page if you would. This is going to be on page 370. These are going to be super short lessons just because they're just building off of things that we've talked about prior to this. Let's go ahead and take a look, if we would, at skill check 1. I'm not going to write these down. I just want to go over them with you. Identify each pair as congruent, similar, or neither. Alright, so number 1, it looks like one's bigger, correct? So I think I would put the old similar sign, or number 2, oh, that's it. Actually, let's do number 3. Number 3 looks like they could be the exact same, because if you flipped it up, it looks to me like it would sit inside of it. So I would say number 3 is going to be what? Congruent. Now let's look at number 2. It can, even though they look to be about the same size, do you guys notice anything different about number 2? I am going to draw this one out just so you can kind of see. This triangle seems to be a right triangle where this one isn't. So, if you can see right here, we got a right triangle here, but this one right here kind of seems to be what? Is it going to be an acute isosceles or a right triangle. Well, we definitely know it's not right. And what does it take to be a acute? Less than 90. If it's isosceles, it's greater. And this kind of looks like it's smaller, so I would say it's an acute. Alright, looking at example 2, if you would. It says, if the triangles shown are similar to DF, so when we say similar, we're going to go ahead and look. It says we have looks like one might be a little bigger, so we got 5, 10, A, B, and C, F, E, and D. Alright, we're going to use something right here. It's, this is how people will do scales a lot, like on maps and such, because I don't know if you guys remember we talked about when we say like 1 inch equals a mile and stuff like that. Well, that means it's to scale. So if you're just thinking about this right here being a scale of the larger. So this one actually has, we don't know this side, and we do know this side. So how can we do a scale? I'm glad you asked. Well, we can take the numbers we know, and I'm going to go to a new page, and we can set it up as AC over DF. So what does that mean? Well, it looks like AC. How's AC running? Maybe I change color here. AC is running like that. It looks the same because, how do I know that? Because this right here, I'm looking at these being right angles. So it looks like this is going to be about the same. So AC is equivalent to DF, so I set it on top of it. Equals, what's the other side I know from this triangle? I know AB, because it gives me A. These are the sides I know, I guess, if you will. So AB is going to be the same as what? DE. So guess what? We can actually put AB over DE. What would be the next portion that we would have to do to this? Well, we're going to have to figure out something in particular. Do you guys know what it is? It's going to be the length that we're given. So we're given 5, 10, and 9. So AC, let's go find AC. AC is what? 10. Okay, so we need to put 10 over let's see, what's the next one? 10 over DF, which is going to be unknown, so that's going to be X. Alright, now we're going to do AB, so let's flip back over here. Where's AB? AB is right here, and it's what? 5. And we need DE, so let's find DE. And DE says it is what? 9. So we need to replace DE with 9. So, who knows what we do next? Let me ask somebody. Cross multiply? Oh gosh, how'd you know that? Because you always cross multiply when we have equal signs. So what does that give us? That gives us 90 equals 5x. Well, if we solve for 5x, it doesn't matter. You can flip sides, put 5x equals 90. Divide by 5. Divide by 5. How many times does 5 go into 90? It goes in 18. So 1x equals 18. So that means we now know the side of what? X. So it is 18. And guess what, guys? That is your answer. Da, da, da. Alright, so let's go ahead now and look at our last skill check here, because I know these have been super short lessons, but they're just kind of like the last portion of the section, just kind of wanting to push you in the direction to understand the difference, because you're going to carry this with you. When you get in like Algebra 1, Algebra 2, you're going to be experiencing this stuff, and especially in the dreaded geometry. Yeesh. But these don't go away, so this is definitely an introductory. And make sure you kind of don't take these for granted that they're super easy. They are easy, but if you do not place your equations like this and set them up, the way they need to be, then you're going to get the wrong answer. So make sure that when you're setting them up, like your similar angles and your similar, like whatever it be, polygons, if you will, make sure that you're lining them up where they look the same. That means if you have a triangle that looks like this, and you have another triangle that looks like, whoa, this. I cannot draw a triangle? I like to try to set them up where they both look the same, so I do both of them like that. And then I would make sure, as you can see here, make sure that you can set them up in this form right here. That should be showing in like 5 seconds. Okay, and now, there it is. Okay, whew. All right, so let's go ahead and look at least skill check 1 to get. Skill check 2, number 1. All right, so we have the figure. And so this one's going to be Q, R, S, and P. And this one's going to be M, N, L, and O. Now we know 6, 3. And here we know what? 4. I don't know why it's not letting me put it there. I'll have to put it right there. 4 and X. Alright, so we need to set up the same formula like we did back here on this portion here, our previous one, if you will. This right here. We want to go ahead, even though it's a different shape, we want to try to make it look exactly the same. Alright, so we know MN and ML, right? And it says that we're trying to find what? PQ. Alright, so one thing that we need to know is if it's a rectangle, 2 sides are the same. So you got 2L plus 2W is the perimeter of the rectangle. So let's go ahead and try to set this up, if you will. So M over N over Q R equals ML over QP. Now I need to go back and find numbers for replacement. So that means it looks like we got, for MN, 3 and 4. So I need to put 3 over 4 equals, let's go back and look again, 6 and X. What do I need to do next? It looks like I need to probably cross multiply. So that gives me 3x equals and 24, right? So then I divide by 3, 1x gives me 8. So x equals 8, and the measure of that we were looking for was going to be what? PQ, or QP, whichever one. So now we can put this over here, and we know this is going to be 8. So that means this has to be 3, 6, 8, and 4. Alright, my dear sweet loved ones, that'll take us to the end of another exciting math lesson. As always, if you have any questions, guys, please feel free to call me, contact me. I want you guys to go ahead and be studying for your test. I'll post all of your homework assignments on the website. Also, I'll make sure that you guys can see the lesson plan, and you guys can study for your test and take notes, whatever you feel like you need to do. And again, if you have any questions, please feel free to call me, and we'll make sure that you guys understand what's going on. And I'll talk to you guys later.